Welcome, everybody. Good morning, good afternoon, good evening. This is the first episode. This is the inaugural episode of a new series that we're going to be kicking off, our Spectra Assure Product Spotlight series. And the goal of these sessions is really to be a little bit more product focused, to really showcase the Spectra Assure solution for software supply chain security, and really showcasing different features and capabilities that map to common use cases that we commonly come across when talking to our customers and prospects. So this first episode will be digging into verifying secure releases with differential analysis, and then we will be continuing the series with other specific use cases, which we'll touch upon. What's coming up at the end of the presentation. So with that, introduce ourselves. My name's Joe Coletta. I'm product marketing here at ReversingLabs. I've been in the application security realm for almost 10 years at this point. And yeah, I'll introduce Dave, who's really kind of the star of the show. He'll be doing our demo presentation. So Dave, do you want to give a quick intro for the folks here?
Yeah, so I'm Dave Ferguson. I'm a director of product management here at ReversingLabs. I've been on board a little over a year now, but I have 18 years in application security in a variety of roles, and was a developer prior to that. But yeah, thanks for joining today.
Right. So with that, give a quick intro of who we are at ReversingLabs for those who may not be familiar. So ReversingLabs, we're a trusted authority in file and software security, and we've been doing this for roughly 15 years. So we maintain a threat repository of about 40 billion files of both malware and goodware, and that number continues to grow with our threat research team methodically adding more files and categorizing new instances of both malware and goodware on a daily basis. So that that threat repository of 40 billion plus files, that puts us 7 times larger than our closest competitors. And what a lot of people don't know is that we actually provide this threat repo to about 60 of the leading cybersecurity companies who trust our data to give feeds into the solutions that you might actually already be using. And more recently, we've actually received a few accolades for our channel partner program, which actually got a 5-star rating from CRN. And we've also been recognized by Gartner as a premier and recognized software supply chain security provider. And this is something that we're actually particularly proud of. We were one of the primary contributors to the latest edition, the 2024 edition of the Verizon data breach incident report. So we're very proud to be part of that as part of our ongoing thought leadership in the space and contributing to one of the most marquee pieces of research in the cybersecurity realm. So something we like to hang our hats on and we're very proud of here. All right. And just to go into what we're going to be talking about just for the episode. So we're gonna have a very limited preamble just to kind of set the stage of what Dave is going to be showcasing. But in a nutshell, we're going to go into what version differential, why version differentials matter, both from a software producer, so the actual developers of software for enterprise buyers, but also for why they matter for the someone who might be in a third-party risk management position. So why monitoring version differentials matters for them, for any companies who might be consuming enterprise software. And then we're going to introduce a concept that is kind of gaining a lot of steam, especially amongst our customers, is the concept of reproducible builds and how version diffs enable that as a common practice within the development pipeline. So Dave will kind of give a quick preamble of what that means, and then we'll kick it off into actually showcasing the demo in action. All right. So in terms of, I feel the best way to kind of showcase why version differentials matter in terms of monitoring them from update to update and version to version. It's best to kind of showcase a real world example of why would that matter in the real world. So for the producer side, for those who are software developers who are actually shipping mission critical products to their customers, we're going to use an example from an open source package that some of you might recognize, UA Parser JS, which was a very popular JavaScript library that was compromised, I believe, late last year. But in this example, an attacker essentially found a way to compromise the maintainer account. So someone who was updating this open source code for a very popular open source package This attacker was able to gain access with gain access to the login credentials and hid malware in one of the components and essentially announce, "Hey, I have this new version available," unbeknownst to the public that this new version was actually a malicious tampering of this software package. So, enterprise developers who were, actually paying attention to their security awareness training and actually installing updates on a regular basis, were actually unknowingly integrating malware into their software, which in turn was then deployed by their customers. We saw something kind of similar to this last month with the XE utility, which was instituted a backdoor through again another popular package, and we're still kind of seeing that was a very near miss in terms of detecting and what the aftermath of that could have been. But we're seeing again why updates can unknowingly become malicious for both the developers who ship the code, but also customers who are installing these updates downstream. And actually, in that same vein, let's kind of go to our next example if we can, in terms of why this would be, why would, for those who are actually consuming commercial software packages on the flip side, here's an example of someone who is who is consuming an enterprise software package where we saw this in the real world. And actually, once I actually go into the detail of the scenario, this might sound familiar to some of you. Um, the attacker was able to compromise the vendor's actual environment and the vendor who actually produced this enterprise software, and he was able to make changes to a third-party library, excuse me, a third-party binary after it was signed, without negating the digital certificate used to validate the integrity of the software. So why is that important? That's important because the customer who's installing the software package, who's checking the signature during what they believe to be a legitimate update from the vendor, cannot tell that the software has actually been compromised. And actually, that software package ended up being a carrier for, again, for malware, which again was deployed throughout their environment, and not only their environment, but dozens of other environments downstream. So again, it's there's a role we're in a situation where not only are the producers of these software packages liable, but also the customers who deploy these specific updates are liable for making sure that they're doing so with due diligence to make sure that there hasn't been any sort of malicious tampering, there's no embedded malware. So there's a role to play. There's a role to play both on the producer side, but also the buyer side. Right. So with this, I want to kind of introduce the process of reproducible builds and how version differential analysis enables that. So with that, I'm going to actually pass it over to Dave because he's our subject matter expert on this concept. So Dave, do you want to just give a quick preamble of what reproducible builds are and why they're beneficial?
Yeah, thanks, Joe. So the webinar topic for today is about differential analysis. And mostly when we think about that, we're talking about comparing like one version to another version of the same software and see what's changed, and see if there's anything that's suspicious or malicious. Sort of a different aspect, or I'd say twist on the differential analysis, is what we call the reproducible builds checks that's in Spectra Assure. So for those of you who may not be familiar, reproducible builds, the concept's been around a long time. It's simply a way to defend against tampering in build systems. So essentially is a software supply chain attack. So the idea is that you have two separate but identical build environments, build systems. So here we see in blue build system 1, build system 2 in gray. And each of those build environments are pulling in the same source code. They're pulling in the same open source libraries. They're building in the exact same way, but they're separate and isolated, in terms of network. They're isolated. So the idea is that you're going to build your software twice in these two separate environments, and you're going to do a check at the end to see if the software is identical, and it should be. But if there was tampering, or say someone had a threat actor had infiltrated your build system, one of them, then that reproducibility check will not pass. And so The Spectra Assure provides built-in capability to do the reproducibility checks. So in other words, we'll compare, software release built from build server 1, software release from build server 2, check them in terms of, is there any changes in malware, is there any changes in terms of behaviors, which would indicate tampering. Now the kind of the classic way to do reproducible build checks is with a file hash. So you compare the SHA-1, SHA-256 hash of the software package from each build system. If they're identical, they haven't been tampered with. The problem is it's very difficult because of timestamps and order of operations in the build process to get a bit-for-bit identical software package at the end. The .NET environment from Microsoft does provide some capability for development teams to enable reproducibility checks with a bit by bit, but the vast majority, it's very difficult to set up and get a bit for bit identical software package. With Spectra Assure, which I'll show in a minute, you'll actually have an opportunity to compare the software packages not by file hash, but simply by behaviors. So if the two software releases are identical in terms of behaviors, which I've identified through our static analysis, then or you can feel some assurance that the build hasn't been compromised. So it's another way to do a differential analysis check you want to do from version to version, but the reproducible builds check is another type of differential analysis.
All right. I think that's a perfect segue to kind of showcase this in action. So with that, Dave, we'll let you pick up we'll let you.
Let me share.
Yep.
All
Let
right.
Dave take the reins and take it from here.
All right, so demo time. I actually have 3 separate and distinct demos for you today. And the first one actually is going to be about UA parser.js, which Joe talked about earlier. So I've opened up Spectra Assure here, and I have an npm project, and within that I have UA parser.js. And so I've actually uploaded to the portal here 3 separate versions of UA parser.js. All right, so if any of you are familiar, the 0.7.29 release was the one that was compromised with malware. All right, and so you can see very quickly here in the 3 separate versions, something's different about that .29 version. You're getting a df fail. Df stands for differential fail status on the .29. You're seeing threats turn red over here under the assessment categories that we have. So something clearly is going on with this .29 release. So let's go ahead and take a look at this. Let's expand this, and this is kind of a summary of what the analysis found in terms of the differentials. So what we did is the differential is between the .28 version here and then the .29 version over here on the left. And very quickly we see that Spectra Assure has said the software quality has worsened in this case, and we're actually getting a differential fail. So we see things in red. This should raise a lot of alarm bells. So let's dig in and actually take a look at the report. And so what I'll do is click on the version. This is going to load up the full report. So right now, again, we see we have one indicator of tampering found. We have multiple items in red, including tampering and malware. Now, part of that, I want to make it clear that UA parser.js, the .29 version, is a known compromised package at this point, right? So obviously, we're going to flag it as malware. And there's a CVE associated with the .29 release. So even vulnerability scanners are going to report it as malware. But what I'm going to focus on in this demo is actually how to know that this package was malicious before it was a known compromised package. So in other words, if you were the maintainer, you were the developer of this package, and you did this differential analysis with Spectra Assure, and you assumed things were okay, what clues would you see in the analysis that should stop you and make you want to investigate? All right, so I want to highlight down here on the left side, we see a section that's devoted to differential analysis information called the version diff section, and there's issues and files. Issues are what we call, I would say, policy violations that you should investigate. Some are more serious than others, but issues is definitely something that you should always take a look at. The file diffs could indicate problem, but it typically, when you're going from version to version of software, files have changed. You know, you've added functionality, you've fixed bugs. So there's obviously going to be file differences pretty much every single time, but it's the issues that's really important when you're doing this differential analysis. So let me click on the three items, the three issues, and let's take a look at those. All right, so all right, the first issue at the top in red is it's a TH, which is what we call our threat hunting policies. And the particular policy that's been triggered is we have detected indicators of tampering that resemble the UA parser JS software compromise. All right, well, that's not a surprise. This is UA parser JS. So that's being flagged because we know it's malware. Okay, so I'm going to kind of bypass that one and go down to the issues below here. So these are issues that have been introduced since the last version. All right, so there's three of them. We have SQ, we have a couple of SQ policy IDs, which stands our software quality policy IDs. And then we have a different TH or threat hunting policy that's been fired up. Okay, the two SQ policies, again, both of these are because UA parser JS.29 is a known piece of malware at this point. So imagine those weren't flagged because we're trying to find maliciousness or compromised software that's not known. So it's a novel attack, right? All right, so this last one is what's interesting. It's detected presence of files with behaviors exclusively used by malicious software. So this is where it goes back to that that behavioral analysis that's part of Spectra Assure's scan. Again, it's just because we hear behaviors doesn't mean it's a dynamic. We're not running the software. Our reverse engineering that we've done on the package through our static analysis process, and we've gotten down to the binary code level, and we can recognize behaviors that are possible by the software by looking at that binary code. So let's go ahead and expand this and take a look. What behavior is exclusively used by malicious software? Well, we see the particular file that has this behavior is called preinstall.bat. So let's click on that. And okay, so we see here now that we get a file hash. It's been classified as malicious. Well, why has it been classified as malicious? Well, we see here that this file has added all of these behaviors, and specifically, all of these were not in the previous version. So we need to understand, you know, are these legitimate? Are these something we'd expect in UA parser JS? Or are they not? Well, as a developer of the software, I would know if they were expected or not. And the real red flag here is downloading a file using certutil. Certutil is a Windows utility. It's typically not used by software. It's typically a command line tool that like a system admin might use. But it does have the capability of downloading software from the internet. And so we're seeing that this .29 version of UA parser JS is using certutil to download a file. Right, so we on our analysis have a policy for that. Like if we see that in software, we flag that as malicious. In fact, there's really no legitimate use for software to download a package using certutils. So that's kind of known behavior of common malware to do that. And so we're flagging that. And so through this differential analysis, even now, imagine this is not a known, if this was not a known compromised package, we would still be able to see that there was something wrong with this .29 version, and we'd be able to stop the release, investigate, figure out what happened. So back on the three versions that I uploaded, obviously once it was known that .29 was compromised, the maintainer of this package, you know, cleaned it up, re-released it as a .30, and now you can see threats is now green on the .30 package, and we don't have any red flags anymore. So so that's kind of the UA parser JS use case and demo. It's the most straightforward of the 3 demos that I'm going to do today, but it's a good kind of illustrative example to explain the differential analysis within Spectra Assure. You know, the way it actually works as a user, using the UI here, you can simply click the upload version. Say you have a .31 version, you want to do the same differential analysis, you just upload the .31 version, and that compares, you know, another row will be added here, and you'll be able to do that same type of analysis looking at the report. All right, so well, let me move on to the second demo related to differential analysis, and this is going to be, I'm going to use a 3CX example. 3CX is a company, and they had an incident a little over a year ago where a software supply chain attack occurred, and they inadvertently released a malware infected version of their Windows desktop app. So let me click on this. I've uploaded the sort of non-malicious, the uncompromised package before, which was the 18.11.12.13. Now there are some issues, like you know, if you expand, you know, there was some Spectra Assure identified a copyleft license. It identified a few vulnerabilities, not unusual. A lot of software has vulnerabilities. Identified some hardening effectiveness issues. Typically, those are like missing compiler flags. They're mitigations that you can add when you're compiling software. And then there's also some revoked certificates detected. That's most likely because the software, you know, this happened over a year ago, and the certificates that were used to sign the files have been revoked at this point. But there's no evidence of malware or anything like that. And so with 3CX, this demo, I'm gonna use the reproducible builds capability in Spectra Assure. So I'm not gonna, in this case, show you a different version. I'm actually gonna upload the same pack, what I'm going to be simulated as a reproducible build. So say this package that I've uploaded was from that build system number 1 that we showed in the PowerPoint slide. What I'm going to do is go down to the bottom and do the upload reproducible build. So I'm going to upload essentially what I expect to be an identical version of that software. So let me do that now. And I need to pull up this one, and I'm going to upload that. So this is going to do our reproducible build check. So I'm not comparing version to version. I'm comparing the same version from 2 separate build systems, right? And that's uploading right now. And it's about 100 megabyte package. So it's going to take just a few seconds to upload. But while that uploads, what I thought I would do is show you the policies in Spectra Assure. So let's go to our documentation. And I've talked about the policies a couple times already. So all of the documentation around policies is here under concepts. And we have various categories of policies, including malware detection, which would be your known malware. And we have, you know, all kinds of detections around vulnerabilities, digital signatures, hardening, sensitive information like exposed secrets. All of these categories have multiple policies that we check against. The threat hunting is the most interesting, in my opinion, because these are actually policies that are looking at the behaviors of software. So, and again, it's the behaviors that we've identified through our static analysis. We're not running or, you know, executing the software in a sandbox or anything like that. This is all through a fast static analysis approach. And so, if you take a look at the different categories of behaviors, some of them are like the one I showed earlier. They're always behaviors that identify malicious intent or a compromised, tampered software, like using that cert util package. There's others that, you know, maybe they're okay, maybe they're not, but they could be suspicious. And so we have various categories or classifications of the behaviors. And those are all going to be identified in the report that you'll see. Now, the other thing that I want to talk about is identifying sort of how prevalent is a behavior for a particular ecosystem. So, a particular language, like say for for NPM or Node.js app, how common is it to see this type of behavior versus maybe a Java application? So those are all going to be rated that way as well in terms of the prevalence. So here's the full list of threat hunting policies, the TH policies, and there's six actually, that will only fire with a differential analysis. And you'll notice that all of these that are based on the differential are referencing a past software supply chain incident. Right, so you see SolarWinds here, you see 3CX, you see CodeCov, you see UA Partial.js, you say the CTX, and then the most recent one, which was just about a month or so ago, was the XZ Utils software compromise. So if we see in a differential analysis the same collection of behaviors in this analysis that occurred in one of these known past software supply chain compromises, then we're going to bubble that up, show it in the report, highlight it, say, hey, this looks like you may be experiencing the same type of attack that happened to these guys in the past. All right, so that's extremely powerful for a product to kind of bubble up that information for you and highlight it, because trying to do that manually would be, you need a high level of expertise and a lot of time to do it. All right, so that's our policies. Let me go back and see where we are with the upload. It looks like, okay, it looks like our upload has finished and our analysis has started. Our analysis is actually completed, it looks like. And yes, so we're seeing now details about the checks that we've performed here. So first of all, we're seeing a lot of red. So initially, we just saw the software package analysis had a pass, an L3 pass. L3 is just our level 3, one of our built-in levels that we have. And then we see also that we have failures for the reproducible builds analysis, and we also have a failure for the reproducible builds check. Let's look at the details on this one, because this is really what I wanted to show. Now, theoretically, if the second build system had not been compromised, we wouldn't see all these red failures. All right, so RB, reproducible builds failure. And we see the reproducible build is not equal to the reference version that we had there originally. The file size is different, so obviously the hash is different. And here's one of those policies I indicated. It's a threat hunting policy that fires based on the differential analysis, and the indicator of tampering that resembles the 3CX desktop app software compromise. Well, that's exactly what you'd expect, because what I did was upload the compromised version of the 3CX desktop app. And so we've matched it, and we see that that's what's happening here. But more interesting down here is under the audit section, we have a whole reproducibility section. And this is where if you want to see the changes here, let's see, changes. Okay, this is what I wanted to show. So we have basically functionality changes. All right, so as a developer, I'm seeing all kinds of different changes that have occurred within this new analysis, and we can filter the changes by only behavioral changes. We can also show things that have been added. And as the developer of this software, this is just all red flags all the way around, because I'm not even comparing different versions in theory. I'm actually comparing supposedly the same build. And sure, I'm not, even on a normal reproducible builds case, I'm not going to see the same file hash. The file hash may be different. But what I should not see is changes in behaviors. And that's the big problem that's indicated here. So So reproducibility checks in Spectra Assure is something we really want to promote and get software producers, especially those companies that are releasing products to their customers. This is an advanced type of check, advanced type of analysis that up until now, other than the .NET development environment, it was not really possible because it was very difficult to get bit for bit matching binaries at the end of builds, separate build systems. So now you have the option to compare binaries based on behavioral differences. You know, if software build number 1 behaves identically to software build number 2, even if the hash is different, you can have some confidence that that the system hasn't been tampered with and your software is safe to release. Okay, so that hopefully that gives you some idea of the reproducible builds feature. So what I want to do now, everything I've shown so far has been using our UI. And so the Spectra Assure analysis can be accessed not only through the UI here by uploading. We have a number of different capabilities to automate things, including a command line interface tool or a CLI tool. And that's very useful to automate the scanning in a CI/CD build pipeline. And so that's what I want to demo for this third and final demo. And for this, I'm actually I'm going to turn my camera off because on this demo, my system tends to slow to a crawl. So I want to make sure I'm not overloading my system here. So what I'm going to do is I'm going to go over, do this demo in Jenkins CI/CD tool. And so I have a Jenkins up and running here. I have a project and I'm going to show a differential analysis using the Spectra Assure CLI automated in a pipeline. So essentially the same type of analysis, but doing it in an automated way and doing it in a CI/CD pipeline. And for this demo, I'm going to be using a GitHub repo with the source code. So my Jenkins pipeline is actually going to build this source code. This is a Java web app called Struts Showcase. And this is a public GitHub repo, so anyone can go and look at this if they want. Essentially, I have a Jenkins file _diff. This is my pipeline script. So it's, as you probably know, it's best practice to include your pipeline script under source code management. So that's why I have my Jenkins file here in the actual GitHub repo versus somewhere else, so I can version control it and everything else. So just quickly make this maybe a little bit bigger so you can see it. To show what this pipeline script does is, first of all, it's building the software. This is, like I said, it's a Java project, so it's building it with Maven. And this is a Java web app. So at the end of this build, I'm going to have a WAR file, which is a Java web application, essentially. And that WAR file is going to be the build artifact that we want to scan with Spectra Assure. And so that's done here under this stage called RL test. And I have a number of invocations of our CLI. Our CLI is called RL secure. In this case, the first step is to scan the artifact. Or what are we scanning? Well, we're scanning that WAR file that I just mentioned that was built in this first stage up here. And after that scan completes, we'll use the CLI to generate some reports with the report command. And we're going to generate an HTML report. We're going to generate the Cyclone DX and SPDX SBOMs. And we're going to generate the RL JSON, which is our proprietary JSON format with all the scan results. And then wanted to highlight also, I'm telling the CLI to do a differential report with the previous version. All right, so this is important to, this is where we're automating that differential analysis with the CLI and a pipeline. And so the report that I get, the HTML report, I'm going to have all that differential information that I was showing earlier in the Spectra Assure UI. And then the final step is just to run the status command that basically just returns a 0 or a 1 if the scan failed policy will get a non-zero exit code, and that'll fail the pipeline, which is what we want in this case. If we're not passing policy, we don't want to continue on. We want to fail the build and want to investigate. And then the post-build steps is just to generate, it's going to publish those artifacts, those reports as artifacts of the pipeline. All right, so now that I've kind of explained the pipeline script, let me go ahead and show you the previous report. So this is the report that the diff report that I ran earlier, and see if it's going to load. There it is. All right, so under the version diff. So again, I'm pulling this report up right within Jenkins. I didn't have to go to the UI or the Spectra Assure SaaS portal. I'm right here in Jenkins. I've got the report. I'm seeing really nothing interesting under the version diff. I see one file change, but that's simply because I ran the pipeline twice in a row, back to back. The only thing that changed was the hash of the war file. All right, so no new issues, nothing to show there. All right, now this is where it's going to get really interesting. I'm going to edit the source code for this Java web app, and I'm going to insert some malicious code, some simulated malicious code. And I will hopefully be able to show you how Spectra Assure picks up this malicious code. All right, so the file I'm going to edit is JSP eval action.java, and I have my malicious code commented out. So let me edit this file, doing this all on the fly here, and uncomment my malicious code. And I'll go back to and show you what the malicious code does in just a minute, but let me commit those changes and go back to Jenkins, and let me launch a build. This is where my system typically tends to slow down, but let's give this a try. Okay, build number 103 has kicked off. So while that runs, I'm going to show you the malicious code, the simulated malicious code that I have uncommented. So it's going to be part of that war file. This malicious code is going to be it's going to be compiled and into a class file, Java bytecode, and included in that war file. So essentially what this does is simulating someone tampering with the source code and inserting basically about 10 lines of code that is stealing the contents of the password file on the system. Right, so it's opening that file, it's reading the bytes from that file, then it's creating a URL connection to this URL. I chose this URL because it's kind of a known, it's in terms of ReversingLabs, like Joe said earlier, we have a huge database of what are safe files, what are malicious files, what are suspicious files, the same as URLs. We know what IPs, what URLs are suspicious or known malicious, and so all that's part of the analysis that we do. And so I'm opening a URL connection to this particular domain, and I'm essentially sending out the contents of that password file as a property of the URL. So essentially, it's in the request body that the contents of the password file are being exfiltrated out of the system. So stealing the data in there. So that's the code that I inserted. Let's go back and see our build. Okay, good. Our build 103 is finished. And let's go take a look at our report right here. Okay, so now we're seeing some interesting information under the diff section. We see 3 files change, but there's one. This is what I remember what I said earlier about issues is really what you want to focus on when it comes to the diff. We have one new issue. Let's see what that is. And we see one issue has been introduced since the last version, and it's one of those threat hunting policies. So we've identified the presence of files containing URLs that use suspicious top-level domains. All right, so that is super interesting. What file was it identified in? Well, it was identified in JSP eval action.class, which is exactly what you would expect, because that's the Java class file that I modified to insert that malicious code. And so, and we can click on that, and we have all kinds of information about what was found in this file. Well, obviously the hash changed, and it looks like it got bigger. The file size is larger. All right, but there's 10 new behaviors. That's what the little green with the plus means. It means this is added since the last version that we checked, or that we scanned. And all of the behaviors you see here is essentially what you're seeing in that code that I added. It opens a file for reading. It reads from files. It contains URLs. It connects through HTTP. It creates a java.net URL connection object. So all of these things that were in that malicious code are being reflected here in the behaviors that we've surfaced in the Spectra Assure report. So pretty powerful to be able to catch kind of surreptitious software supply chain attacks. And that's what we're all about. It's not just about vulnerabilities. We do scan for vulnerabilities. But today you need to do more than that. And probably maybe turn my camera back on now that the demo's done. So it's important to do more than just scan for vulnerabilities. Tampering, malware, secrets. Spectra Assure can analyze all aspects of software. That's kind of our specialty, and it's a technology that's been around for 15 years now. It's just recently ReversingLabs has been applying it to the software supply chain security space. And it's very powerful in what you can do with this static analysis, especially when it comes to tampering. I could do more demos like this, but hopefully those three gave you a really good idea of what can be done with Spectra Assure in terms of differential analysis and even the reproducible builds aspect. So with that, Joe, I'm going to turn it back over to you, and maybe we want to do Q&A if we have time. I think you're on mute.
I am on mute.
There you go.
About time I gave you a chance to rest your vocal cords. Let's open it up to questions. I'm going to bring it back here. So we have a couple questions from the audience. First one being, let's see. Yep. First question coming in. You showcased the Jenkins environment when you were demoing the CI/CD tools. What other CI/CD tools do you support?
Yeah, so that's a great question. Yeah, Jenkins is just one CI/CD tool out there, pretty popular one, but there's dozens of others. Now, the good thing is the Spectra Assure CLI tool it can be used in any of them. Like you can script a solution that will implement the scanning in any tool. So whether TeamCity, GitLab, GitHub Actions, Azure DevOps, Circle CI. I mean, any of them. We are starting to roll out, however, kind of native plugins for different CI/CD tools. Like I think it was about a month ago, we released an Azure DevOps extension. Today we have GitHub Actions that you can start using. They just make it quick and easy to implement the scanning in those environments. But again, with our CLI and then also our APIs, we have a bunch of REST APIs in Spectra Assure that you can also kick off scanning that way. I mean, the big difference there is when you're using the CLI, the scan is running local to wherever, like the Jenkins demo that I did, that scan was actually running local within Jenkins, the runner. With the APIs, you can basically upload the software package to Spectra Assure, and then the scanning will take place there in the SaaS portal. So a lot of different options there. So I'm 100% confident. Okay, we'll get 99% confident that we could have the Spectra Assure scanning work in any CI/CD tool.
All right. Next question coming in, files around file formats. What are there any specific file formats that that Spectra Assure supports that you wanted to highlight?
Yeah, there's definitely file formats that are supported, and kind of the way the scanning works, to just to quickly touch on that is, you can, like I showed that war file with the Stretch Showcase Java app. That's one file type, the war file, that we can unpack and scan. And by unpack, I mean we know it's a war file, we know how it's structured, so we can rip it apart and see what's inside. And then our scanning is recursive. So, within that war file, there's probably a bunch of jar files. So, well, we know the format for that. So we'll unpack those jar files, and we keep unpacking recursively until we end up with probably many thousands of files. And we analyze each one with that huge file reputation database that we have of 40 billion plus files. So in terms of files that we support, it's all documented on our docs page, which I pulled up that docs page when I was showing the policies. We also have a section called supported file formats. So you can always go there. It's docs.securesoftware.com. It's all on there. And I think don't know the exact numbers because it's always growing, but the number of file formats that we can unpack and deconstruct is around 400. That would include like exe files, MSI files, tar files, zip files, war files, just to name a few. You can throw almost anything at Spectra Assure and it'll figure out what it is and scan it. And then there's some files. I think the total number of file formats that Spectra Assure recognizes is around 4,800. But some of them you can't unpack. Like, for example, a text file. Well, you can't unpack that. But we recognize it's a text file. Same thing with, like, script file, like a shell script or a PowerShell script. We recognize those file formats. It's just we don't unpack them because there's nothing to unpack. But we're always adding more. Recently, we've gotten a lot of requests from customers. They want to just throw like a virtual disk image at Spectra Assure, like an OVA or a VTI. There's probably dozens of different virtual disk image formats. And so we support a lot of them. We don't support every one, but we're adding all the time. So yeah, all the documentation is out there on our docs.secure.software. Oh, one more thing, Joe, related to that. You're also not going to find just the file formats that we cover, but also the communities or the ecosystems. For example, the Java ecosystem, the Node.js ecosystem, .NET. So kind of the developer, like what kind of a development shop are you? Like the ecosystems that we cover there are included. And the important thing there is open source libraries. Like, do we support vulnerability detection, malware detection, secrets detection in those different types of open source libraries? They all have their own package managers and file formats. So you're going to find information about what communities we cover there as well.
Awesome. Final roll call, last call. Everyone to address it for questions for Dave or anything related to what you saw seen during the presentation. Just checking the tab here. I think we got them all. All right. We're getting close to the top of the hour anyway. So I want to thank Dave. Thank you so much for going in depth into all those different scenarios relating to version differential analysis, both within the portal and within the CI/CD environment. That was awesome. So thank you again. For the folks on the call, we have a lot more presentations coming up, both later this month and early next month. The next episode of the Spotlight series will be on June 27th. We will be assessing third-party software risk without the need for source code. So tune in for the next episode of this series, along with a slew of other presentations coming up. We have our RSA conference roundup with our own Paul Roberts and Chris Romero and Tanisha Martin. our insights from the Verizon DBIR report we're going to be diving into, and then um, a presentation from Amy and Josh and Knox. He goes by Knox, by the way, that is his official title, about outpacing virus total and what we can do in relation to malware analysis and threat intelligence in that space. And we also have the Dr. Jessica Parker, who was at our booth at RSA doing a book signing. She'll be doing a live presentation with Paul later this month, talking about her new book and sort of the human elements of cybersecurity and hacking. So some interesting stuff going on. And it should be noted that if you do attend these sessions live, you will actually get CPE credits. So feel free to spread the word to your colleagues if they're looking for any sort of continuing certification, or if they need the credits to achieve certification. These presentations will go towards that. So spread the word. But with that, thank you all. Thank you all for coming. Like I said earlier, this call will be on demand. So if you want to forward it to any of your colleagues, by all means, feel free to do so. And we hope to see you in the next one. Thank you all. Have
Thank
a
you.
great day.